Let's talk about what a Cauchy sequence is in mathematics. This is day 15 of Let's Learn Real Analysis on TikTok, and today we're going to be talking about a property that actually can show us that a sequence converges without knowing what the limit is. The definition's been up here, and what it says is that eventually all of the terms of our sequence are getting close, not to a particular limit, but to each other. And it turns out, although it's not so easy to prove, that this property implies that there actually is some limit that all of the terms are getting closer and closer to. We are going to prove this fact over the course of several days. It's actually a great excuse to introduce something called subsequences in the Bolzano-Weierstrass theorem, which helps us prove this, but also gives us another tool in our toolkit. Now, when I talk about this in class, I also show my students a very similar looking property, which is this one here, where we don't require that all the terms in the sequence are close to each other after some point, but just that successive terms are close to each other. Now, you may think if a sequence has successive terms that are within 10 decimal places of each other or within 1,000,000 decimal places of each other, that eventually the sequence has to stabilize, it has to converge. But actually, this is not the case. For instance, the sequence square root of n clearly is going off to infinity, because if I pick bigger and bigger numbers, the square root gets arbitrarily large as well. However, you can show, and put your proof in the comments if you have any ideas, that actually the difference between successive square roots, like the square root of 1,000,001 versus the square root of 1,000,000,000, you can make that as small as you want, and that will continue to be small forever. By the way, the whole point of a first course in real analysis, which is what we're doing here, is to build intuition and practice writing proofs, writing inequalities. At my university, students get advanced writing credit for this because they're writing so many different proofs every week. Some people have asked if there are different types of real analysis courses, and the answer is totally yes. Real analysis is actually a field in mathematics, and there's everything from introductory courses like what we're doing here, and graduate level courses and research level courses as well. But whatever you want to call this course, it's really the first course where we go down to the bare bones of the real numbers, and we prove everything that we have, all the facts from calculus, just from those axioms of the real numbers that we talked about a few weeks ago. So stay tuned next time when we're going to talk about subsequences, and on Monday, we're going to do the Bolzano-Weierstrass theorem.